Now let's start off with a few simple definitions. Here I have defined a gene as the basic and functional unit of heredity, while an allele is simply an alternative version of a gene. Common examples that I use to illustrate this are flowers, if flowers, say, are red or white, or if their leaves are rough or smooth, or even spiked or not spiked. Now, these alleles can either be dominant or recessive. And so, depending on where you look, you may see this represented in different ways. But here, I'm going to be simply indicating a dominant allele with a capital letter and recessive with a lowercase letter. And the combination of these alleles for an individual is what we call the genotype. And these individuals, we would call them homozygous or heterozygous. So, homozygous coming from the Greek homos, meaning the same, and heterozygous coming from the Greek heteros, meaning different or other. So, a example of this, let's look at the flowers. So, if let's say that the dominant allele is red flowers and the recessive allele is white flowers, an individual who's homozygous dominant have red flowers, homozygous recessive white flowers, and heterozygous individuals also have red flowers because even though they have that recessive allele, the dominant allele is always expressed when it's present. Now, these colors we just went through, that's the phenotype. So it's the physical trait determined by the alleles. Let's look at Punnett squares. So Punnett squares are a simple visual tool to predict genetic inheritance. The genotype of each parent are placed on the outside of the Punnett square as seen in this diagram below. So on the outside along the top here, I've put the genotype for parent 1, who is a homozygous dominant individual, and parent 2, who is a homozygous recessive individual. And each of the four possible outcomes here are heterozygous individuals. So carrying on from the previous example with flower color, where the dominant allele gives you red flowers and the recessive white flowers, here we can see that parent 1 has red flowers and parent 2 has white flowers, and each of their offspring all have red flowers because even though they have that recessive allele there that would give them white flowers, they all have that dominant allele present and they're all therefore red. Alrighty, so to understand Punnett squares a little bit more, let's go over an example. So in this example, we're looking at the gene for being able to roll your tongue. So let's say that it has two alleles. The dominant allele, represented by an uppercase T, allows you to roll your tongue, while the recessive allele, shown by a lowercase t, does not. So in this example, we're looking at a father who is not able to roll his tongue, and a mother who is heterozygous for the tongue rolling gene. So what proportion of the offspring will be able to roll their tongues? To find this out, we can use the Punnett square. So we know that the father cannot roll his tongue, which means that he doesn't have a dominant allele. So he's going to be homozygous recessive. The mother, we know from the question, tells us that she is heterozygous. So she will have an uppercase T and a lowercase t for her alleles. Now we can use the Punnett square to visualize all the possible outcomes that we have. So in this box, we'll have an uppercase T and a lowercase t. Here, also an uppercase and a lowercase. Down here, lowercase, lowercase. Here, we will also have a lowercase and a lowercase. Sweet. So what can we find out from here now that we filled out the Punnett square? The question is asking us what proportion of the offspring will be able to roll their tongues. So we know that in order to be able to roll your tongue, you need to have the dominant allele. So we have the dominant allele here and a dominant allele here. However, in these two boxes, there's no dominant alleles. these are the only two that have a dominant allele and will therefore be able to roll their tongue, giving us a proportion of 2 out of 4, or 0.5. Now down here, we see recessive, 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 recessive. So from here, just for a bit of additional fun, you can see that 2 out of 4 of the outcomes, or 0.5, will not be able to roll their tongues because they don't have the dominant allele.